College Biology. This is our first video on energy carriers. An energy carrier is a molecule that stores chemical energy. They themselves can be transported to where energy is needed, and then that chemical energy can be released, and it can help other chemical reactions occur in the area. So let's take a look at some of our energy carriers. This is glucose. We know it's a carbohydrate, it's a monosaccharide. This happens to be in its ringed form. It is made during photosynthesis, and its formula is C6H12O6, and it is the gold bar of energy. If energy is money, if we're making that analogy, then glucose is the gold bar. It's got a lot of energy stored in it. That's good because it's an effective way to capture energy from the sun, and it's a pretty good way to store energy. Unfortunately, if we spend glucose, if we're like, yeah, let's get that energy out of glucose and do some chemical reactions, we're releasing so much energy out into the environment that a lot of it is wasted. You just can't go shopping with gold bars. That's not a thing that works. So it's a great energy carrier, but it's not awesome for helping us do chemical reactions. Now, this guy is ATP. Let me scooch over a little bit so we can get all of that in there. Almost. This is ATP. It is adenosine triphosphate, and it is an energy carrier also. It is a modified nucleotide. It has this purine, which is adenine over here. It's got this sugar, which is ribose. We know it's ribose because it has this oxygen right here. If this oxygen were missing, it would be deoxyribose. But ATP has ribose. ATP is made of ribose. And it has these three phosphates right there, all connected in a row. ATP is made during cellular respiration, and ATP is a great energy carrier because it is our dollar bill of energy. If we go back to our analogy, it's quite easy for the cell to spend ATP to fuel chemical reactions without wasting very much energy. It's really difficult for the cell to make change, if you will. So if something costs 80 cents and ATP is $1, well, that 20 cents is just going to go out into the environment. We're not going to get it back. Whereas if we used a gold bar, well, then we would be wasting a whole lot. So ATP is superior, has some advantages over glucose for actually fueling cellular reactions. So great. Now, what does the cell use this energy for? Well, there's three major categories, three ways to organize how the cell is using energy. One, transport. Moving molecules requires energy. So active transport, endocytosis, exocytosis, these types of things that we discussed last semester. If you're going to move things around, you're going to need energy to do that often. Cellular signals, electrical signals between nerves, coordination between cells, these types of things would require energy. And finally, this example, non-spontaneous reactions, like this lady rolling a ball up a hill. Sometimes there are things that will occur on their own in the cell. If we needed that ball to roll down the hill, all we would have to do is step away, and that ball would do that all on its own, spontaneous reaction. But there are some reactions that would require an input of energy, non-spontaneous reactions. We're going to stop here. In the next energy carrier video, we're going to talk about spontaneous versus non-spontaneous reactions and how ATP can facilitate and influence those things. I hope this helps. Struggle well.